Okay, in this video, we're going to be talking about composite surface areas. So we're going to be taking things that are normally individual, like we have been doing, like this is a cylinder and this is a cone, and we're going to be, well, combining them, like putting that cone right there on top of that cylinder and finding the surface area of that thing. Okay, and what you will recognize, hopefully, is that when we combine different things, when there are additions, okay, the surface areas change because we can't always touch the surfaces. Like right now, when I put the cone on, I can no longer touch this surface. Okay, so that surface is not going to be added to my total surface area. Okay, nor is the base of my cylinder, my cone here. So there are some very interesting things that you need to think about every time we do these composite surface areas, and we are adding or we are combining two different shapes together.
Can I destroy this now?
Okay, here's the first example on your notes. What we have is a cylinder here and a cone. So here, watch this quick video that I made using Play-Doh so we can explain what's going on here. Okay, so hopefully you watched that little snippet there that I made out of Play-Doh so that we can talk about this. Okay, now remember the tangible surfaces here. So we have two different shapes. We have a cylinder and we have a cone. And those are the formulas to find the surface area of both your cylinder and your cone. Okay, but hopefully you know from that previous video that we can't touch all of these surfaces. So I can only have a one base cylinder, right? I can't touch this base up here. That would be the top of my cylinder. Okay, nor can I touch this base of your cone. Okay, because that's the same exact part. These are the two things that are glued together, and once they're glued together, we can't touch them. So we can't add them into our formulas. Okay? So I'm just going to use this formula, pi r squared plus 2 pi r h, and this formula, pi r l, in order to find my surface areas. Okay, so I have a radius of 8 and a height of 12, and this is my slant height, so I have everything that I need to do these calculations. Giving you all that information. Okay, so pi r squared plus 2 pi r h, and then pi r l, and then we get 336 pi for the total surface area of this combined picture. Okay, so next example. Okay, here's the second example, and you can watch this little video and kind of think about what surfaces are involved here, what shapes, which ones you can and can't touch. Okay, so once you watch that, come down here so we can, there we go. So we can talk about this little problem. Okay, now we have two things here. We have a cube. Okay, and a cube is 6x squared for the surface area. Okay, specifically for a cube. And then there's the cylinder, which again is 2 pi r squared plus 2 pi r h. Okay, now as the video said, we can't touch all 6 surfaces of the cube. Okay, we are missing this top part here. So there are not 6 sides, but rather 5 sides to this cube that we are able to touch. Okay, and for the cylinder, notice this cylinder is perfectly cut in half. Okay, it has half of the base, it has half of the lateral, it has half of everything. Okay, so this formula turns into something like that. Okay, so we're going to use these two formulas in order to find the surface area of this cube. Okay, in fact, the radius here is 2. The whole entire diameter is 4, so it has a radius of 2, and it goes like this. We get 80 for the cube, 80 square inches of the cube's tangible surface, and 12 pi square inches for the cylinder. Okay, now we add these together, and we can only add them together in your calculator because this thing has pi and that thing does not. Okay, so you can't add something that has pi to something that doesn't add pi. But we can put this into your calculator, 80 plus 12 pi, and that will give us a decimal approximation. 117.699 square inches would be the approximation, okay, if we were to round to 3 decimals, but this would be the exact value, okay, because there's no decimals involved, and there's a pi there. Okay, so one more example, and then hopefully you'll have everything down. So here's your third example. We call this a grain silo, but it's basically, once again, like the video says, a cylinder and a hemisphere. Okay, so watch the video and then we'll better be able to understand what's going to happen in this problem. Okay, because once again we want to calculate the surface area. So we have a cylinder, right? The round part is a cylinder. And we have a hemisphere. Okay, so a cylinder has the formula 2b plus pH, and the hemisphere has the formula 3 pi r squared. But once again, we can't touch all these surfaces, right? We cannot touch the top half of this cylinder, so not 2 bases, but rather 1 base will be used to calculate the surface area. And not 3 pi r squareds, but rather just the curved outside part, 2 pi r squareds. Okay, where this thing has a radius of 4. Okay, that has a radius of 4 also. Okay, but the height here is going to be 9, and we can use this 9. The whole entire thing is 13. This much is 4, so the height of your cylinder has to be 9. Okay, so you can use some brain power there to do those things, and then the calculations look like this. Just like that. So here we have pi 4 squared plus 2 pi times 4 times the height of 9. Okay, 16 and 72 is 88 for the cylinder. And then 2 pi 4 squared, so 32 pi for this hemisphere on top. Added together gives you 120 pi square meters as the total surface area for this silo. Okay, so remember when you're doing these problems, you have to think about what surfaces can you touch and what surfaces can you not touch, because you will not be adding in or using those surfaces in order to do the calculations for your surface area.